Okay, welcome to our math colloquium today. Today, we will have a talk from Professor Marco Pollanen from University of Trent, Trent University in Ontario, Canada. Professor Pollanen is a specialist in technology math, and financial mathematics. He has got a major award from the university recently on the technology in mathematics. We are happy to have a talk from Professor Pollanen today, and he will talk on online technologies for improving student engagement in mathematics. And in the talk, we will have we allow questions and discussions in between. So feel free to ask any questions during this presentation. And yes, okay, we welcome with a big applause.
Thank you for the introduction. I'm going to talk about online technologies for engagement. And let's see, go. Okay, so what I'm going to talk about in this talk is mostly about communication technologies and formula input and so on. So the example I'm going to be giving is from education, which will be mostly about online office hours, and then I'll talk more generally about math communication and why it's difficult and so on, and then talk about sort of how we interact with mathematics, formulas and so on, expression entry, and what improvements can be made. So if you look at the issue of introductory mathematics service courses, I think that there's sort of a very low level of help-seeking behavior in mathematics classes. If I look at a course maybe in the arts, there's often professor will sit down and have a long discussion with students, lots of questions, right, and interaction. And in math classes, I don't know maybe what your math classes are like, but my math classes, very few students raise their hand to ask a question. And if they do, it's only that maybe 5% of students are actually very engaged in the class. When it comes to office hours, very few students actually come to my office hours. I mean, they come, but it's always the same students. It's that 5% of the class that you're really engaging. And if you ask students about, in service courses, about their attitude towards math, most surveys I've seen say that about 85% of students have an anxiety towards math. A lot of students say they hate math or the math hates them. So math anxiety is a very real, math phobia. Students think that they're unique in their inability to do math, and this is a big problem. Now, when it comes to office hours, there's lots and lots of studies that say that increased contact outside the classroom, or even asking questions in class, is something that really correlates positively with student retention, academic performance, and their satisfaction. And what we have is, a lot of studies talk about, when I talk about online office hours or other ways of contacting the professor. There's in a lot of subjects these days, you have a lot of students now engaging with their professor through chat apps or through social media and so on. In mathematics, it's very rare. I don't know of many professors who are very engaged online. Yet studies show that most students, post-secondary students, would want more virtual communication and that they would use it if it was offered. So a long time ago, I created a chat program, basically, for online office hours. Now, this is not the current technology, but it put things in the framework of where I'm going to go with it. But it was just basically a whiteboard communication tool designed for math. And it was a Java-based, which at one point was you could use. Now Java isn't supported anymore, and so we have to move on. But basically, this is what it was basically a drawing program. Essentially, you draw your equations with drag and drop, resizable symbols. You have a chat window where you have a conversation going on, and
you can use your mouse to point out.
Oh, okay. Yeah. All right. Sorry. Yeah. So you can import diagrams, and you can write your content with drag and drop symbols and so on, and you have your conversation window. Now we did a study on its use in the first and second year service courses, and when I wrote the program, because because I'm lazy, I did not make a floor manager. There was no login. You would just choose a name and come in. And so essentially students could show up anonymously. And what happened is most students chose to show up anonymously. Only about a third of students would use an identifiable name. So 2/3 of students, I would say 1/3 of students clearly use. 1/3 of students clearly used a name which was not recognized by anybody, right? Like some made-up name. 1/3 of students used a name which could be a name that maybe other people might know because it's their kind of like their email password or email name. But 1/3 of students maybe used their their real name, Mike or something. But what I found is that it was surprised because the very first office hour I saw a huge increase in participation. In fact, my first office hour, 40% of my class showed up to the office hour online. And so you're talking about dozens of students at one time. And in another instructor who was actually a very popular instructor, he tried this. And so I'm not as popular as him. He's one of those guys that normally already had a lot of students in his office hour. He had 80% of his class came to his office hour. So if you're popular in real life, you're popular online too. So that's and many of the students they stay now they stayed for the entire hour, not just to ask their question, like they come to your office and leave. And there was also students who were helping other students online. So it's a very different dynamic than we were used to. It's the social engagement in mathematics. And so we surveyed students about what happened because we were kind of shocked. I was shocked that all these people would come, and it's very exciting actually when you have 30 students and there's questions going back and forth. It's actually you're almost like on a high because you're like, I got to answer all this stuff really quickly. But the students would say stuff like, it's convenient because many students have the same question. So then they realize that hey, they're not alone in struggling in math. They see that people have the same questions. They're comfortable with online technologies. They say. They like it because it's less personal. They don't, they feel intimidated asking a math professor a question directly, maybe social status or something. They find that it's convenient because they're in their room with their resources. When a student comes to your office, they don't have, you have the wall of books. You have all the knowledge. And they come kind of in a naked way in the sense that they just come with a piece of paper and say, I have this problem. And you can't, whereas in the room they talk about, a lot of the quotes we're talking about, they have all their books laid in front of them, and they can now access information, and they can search for stuff, and they're on a more equal footing with you in asking a question and working through problems. And even students, the 40% who came to my office hour, there's some others who said they would have come maybe if they had an they attended, they lived off campus, and it would be very convenient if I had more of these office hours. Now, on the issue of anonymity, this was interesting because lots of students, I didn't ask them specifically about anonymity, but many students started writing about the fact that they were anonymous was very important to them. And they would say that they're uncomfortable approaching a professor about problems. Okay? And they were talking about, a lot of students talked about stupid questions. They're embarrassed about asking a stupid question, right? Even though you tell them no question is stupid, they think that there are stupid questions, right? They talk about it's it's easier to take a risk of asking something when nobody knows who you are. It's interesting because some of the students clearly are afraid of me knowing who they are. Some students are afraid of other students knowing who they are, but they're not afraid of me knowing who they are. So some students would later on say, hey, I was the guy yesterday from class, online, and I was, whatever, Kermit the Frog. Whereas other times, and so they knew that they were just hiding from their friends. Whereas other times, students would have a conversation, and somebody would say, hey, Mike, and they were like, then they were embarrassed because they were their friends knew who that person was online, but not me. And then they were like, you could see that they were embarrassed that their cover was blown, right? So there's different reasons why people are afraid. But basically, there's a lot of students talked about embarrassment. Now, the interesting thing here is that if you look at every quote here, so if you look at all these quotes, the interesting thing is I have a lot of quotes. I have a lot of quotes about anonymity, and I didn't ask them. They just came up with this. They talked about their fears, but they're all written in third person. Nobody actually said, "I'm afraid." It's all written in the way that and I don't understand the psychology of it, but nobody said, "I'm afraid to ask questions." They always said, "Some students might be." So not a single student. I have maybe 50 quotes, and all of them are in third person, like that. So I don't know what that means, but. But anyways, all what I wanted to say about this was that I think that students really want to communicate in math like they do in other subjects, right? They want to be engaged. And I think that there is a great pedagogical potential. I think that students will learn better if we get them more engaged in conversation, asking questions, giving their ideas in math. And I think that even we could develop tools for even social media, more getting involved in this sort of greater discussions. But I think the problem comes down to that we need to build the technologies to do this. And I really don't know of a lot of good chat software for math, right? And so that's kind of what my goal is, to sort of think about what are the barriers to creating technologies for math so that you could be on your mobile phone and doing some sort of Twitter or something with math or whatever. So let me first talk about mathematical communication and my thoughts about what difficulties are, and then we'll talk about technology. So what's unique about math is I think that math is something that's unique in the sense that it always requires a facilitating technology, like, for example, the blackboard or a piece of paper. You have to write down to show things, and not even just show things, but it's hard to even hold mathematics in your head. So this is why I have a picture of Archimedes drawing in the sand. So if Archimedes was drawing in the sand to hold his ideas in his head, I think we all need that facilitating medium. And now, if you look at math as a language, mathematical expressions, math is a two-dimensional language, right? So in text, if you write down something in text, it's just one character follows another, right? Text is one-dimensional. Okay, math has a two-dimensional layout in terms of notational structure. There's also other symbolic and diagrammatic content. And there's also a lot of different symbols. So there's a lot of symbols, and there's also a spatial problem of layout. Now, if you look at all the technologies that are being developed for communication these days, they're all essentially, there's some image stuff where you take images and you send them to people, but for the most part, everything is text-based, right? Whether it's chat or instant messaging, it's all about sort of text, and nobody's really developing stuff for communicating more complicated stuff. And it's not just math, but there's a lot of symbolic sciences, like chemistry or other things, that really need better tools for be able to communicate this, and they're not really being developed in the app world, right? And so, but you can write. Of course, we can write inline expressions like in LaTeX, right? We can write that linearly. But what problem is that those type of technologies are not good for students. Now, students are what I would say I call a novice user. So, kind of a casual user who, we learn to use tech, and we have the time to invest and learn. But let's say a student wants to ask you a question. They don't want to learn something before coming online to ask you a question. You need a technology where they can ask their question right away without having to learn how to use the technology, right? So it's very different than any other sort of mathematical input technology. And the students try this, but they come up with ambiguous statements. So, for example, if you were to look at like 1 divided by x plus y, I would say this is, you could think of order of operations, but that's not the correct way in terms of a student's thinking of this. Some of them might think of this as, some of them might think of this visually. See, if when a student tries to draw you and send you an email, right? If you see an email with mathematics in it, and you try to just understand what are they writing. See, some of them are actually thinking of this as a picture. They're looking at that as 1, and then you tilt your head, and there's a fraction bar. Some of them are, so they're not necessarily thinking, the same way as you are, because they haven't been trained in how to write mathematical expressions in text. And so you end up with there's also the problem, what do they do with exponents, and there's of course the problem of symbols. There are lots and lots of math symbols too that they have to describe. And so something as simple as not less than or equal to, right? It becomes, in an email, becomes difficult, right? Because, well, do they describe it? Do they, write it out? And so when you talk about mathematical entry of expressions, you basically have 2 problems. One is that there's the symbol problem. So every piece of software has to solve these 2 problems. There's the symbol problem, that there are hundreds of math symbols. Even in a service course, you might have to use some Greek letters sometimes or some other things. I mean, there are still if you start thinking of how many symbols you have, there's actually quite a few that are needed. There are thousands of math symbols, but the student might not need all of them. Then there's the layout problem. How do you solve the problem of 2-dimensional structure? And then you have to think about what your hardware constraints are. Now, you have the computer and mouse, the old system, the old way of doing things. Now you have touch devices, right? Sometimes you have digital pens, and some of them, like on the Apple, are kind of the old, like if you have an old iPad, not the new one, they're stubby pens. They're not accurate. They're more like the finger, right? And you could have speech recognition or gestures. I mean, but this is basically your list of what is possible in terms of interface. So let's talk about now how do we solve the interface problem. So let's talk about how other people do it. So first of all, there's TeX. So TeX solves the symbol problem by mapping keywords like alpha to the letter alpha. So there's a transparency issue there because you have to know what the keywords are in advance. It solves the layout problem by, of course, brackets, right? You use lots of parentheses or brackets or whatever, curly brackets. So, but that really is putting things in a nested structure. So you're really having to parse things then. So you take the burden of this expression. It becomes a mental parsing exercise to read it, right? The alternative, and those are difficult for novice users because they neither parse things. They're students, so reading expressions that are parsed is actually very difficult sometimes for students. And the transparency issue, that's an issue as well. So the alternative is, of course, the structure-based input method, right? Now, the structure-based, most equation editors you've seen in any software are structure-based. They separate the math structures from the symbols, so that's how they solve the problem. You have, and you end up with an expression. Everybody's seen this, the boxes, and you enter stuff. Now, that is, so here's an example of a statistics formula, right? And even this simple formula, which is, high school level, actually has a fair amount of nestedness, right? You have the square root of, this and this and this inside. So there's actually a fair amount of structure in it. And if you get to a multivariable statistics class, which could be taught in first year, it's actually a quite difficult expressions. And so I think the one thing that happens with people when they do this sometimes is if you observe people, and we've done a study where we observe people writing stuff, they get stuck. And actually, you know what? I got to admit, I tried some equation editors where I tried to do something and then I get stuck and I have to restart. because you have to put the structures in the right order. So you have to parse things to do that. So,
we have solved that problem.
Yeah. Okay.
I found an answer to those in Korea.
Okay.
And it resolved all the problems related with those.
Okay.
So now I can communicate. I have communicated with my students on solving mathematical problems with mathematical symbols without much difficulty.
Okay.
It's much efficient than any other earlier approach.
Okay.
I will show you. Yeah.
So So basically, in terms of the structure-based editors, the main problems with them is that you really have to pre-parse the expression, right? And then you have to write the expression often in a different order, and actually it usually ends up being in the opposite order, because when you watch people write on paper or a chalkboard, they write usually from out to, like they start, they're often top left down, right, but it tends to go from out to in. And what happens is if you're asking a student to pre-parse something, now if this was used as an input thing for a test, for example, or even communication, you have two tasks which are opposite. One is you're trying to solve a problem or communicate something, and the other one is you're trying to parse this expression for no other reason other than to input it, right? Which makes it, is distracting to your main task. So that's a dual task destructive interference. The other problem is with these editors is that they tend to defy the general notions of sort of what you see, what you get. Like if you cursor around, and there's no way of knowing which way, because it's two-dimensional, if you're going to put the cursor key to the left or right, where's the cursor going to jump? Is it going to go jump up, or is it going to go jump down? Is it going to jump out of the nestedness? The navigation is, there's no general principle for that. And it's different between almost every interface has a different navigation principle. And like I said, users get stuck, and they often can't complete their expression. Now, the other thing is, from a communication point of view, this is, those were input technologies for writing, mostly for writing documents, right? I think that if you're talking about communication, one of the things is that you often want to do something that's a little different than writing a document. You want to take an expression, you want to manipulate that expression. For example, simplify something. So you take if you're in a structure-based editor and you want to simplify something that has something inside, sometimes it's very difficult to start canceling out. So you want something that you can modify, and often copy, paste, modify, because you're showing somebody steps, right? So it's a different task actually than those. So let me just say about something like pen input systems for a minute, because people always ask about that. And the advantage of these is that it's closest to the chalkboard model, right? The dream is that you write mathematics with a pen, and the computer recognizes it, and it's just like the chalkboard. Now, the first problem is you need special hardware, and had Apple decided a long time ago that the stylus was the thing to do, then we'd all have a stylus, and we would have no problem. But we still would have a problem, because it's difficult to recognize handwritten mathematics. Now, this math writing here is about my neatest handwriting. That's actually neat for me compared to what I usually write. So what happens when I tried to run this on a very sophisticated algorithm for handwriting recognition of mathematics is
Even for that, if you use the Galaxy Tab, Galaxy Note, then actually they do recognize those pretty well and do the Mathematica to show the computational.
I
think that's easily understand that. I have done it.
Well, it depends on my handwriting, but it also depends a little bit on
you are using the effort.
But we'll get to this. It actually, one of the things actually, it depends also on, there's a little bit of cheating that goes on with the software, in the sense that, the question is, do you recognize it while you're drawing it, or when it's finished drawing it? So there's a question also about so the character one of the problems though is character recognition failure can be high, right? And the other problem is a symbol problem, is that in mathematics there's still a large number of symbols that are very similar. Like if you're doing Korean handwriting recognition, right? Korean handwriting recognition is something which is very simple, because there's about maybe 2,400 Korean characters, like blocks, right? And there's about as many math symbols, right? But the Korean characters, of course, stroke order is important and all this, so it's a very simple problem. With math symbols, a lot of symbols are the same or similar, right? And even finding the difference between, let's say, from a layout problem, 1.2 versus 1.2, is something which is difficult. I mean, unless you have proper context, right? So you often have to sort of train the user on make sure that the user sort of practices a little bit using the system, and also they need to adjust. The system has to learn this user's writing a little bit, and on a little bit the software as well. So let's get back to this chat program before, right? So this was just made before as a simple paint program, but it did get me thinking about things at some point, especially when Java died. And this was just, you draw your picture, right? I mean, you could draw your picture with a pen or with these drag and drop symbols. And you can think about this as a hybrid. It's a drag and drop. It uses resizable math symbols. It has the palette, so if a student doesn't know their symbol they want, they can find it somewhere. It would allow pen input if you want, right, at the same time, so if you have a different type of device, and you can put content such as math diagrams. But the problem is that was just as a user interface model, it was a paint program. You're drawing like pixel-based paint, which means it's difficult to edit, modify, difficult to reuse content, right? And as time goes on, when you do online office hours, you realize the volume of students you're dealing with. It's actually very important to have a system where you have reusable content, because if you're dealing with 30 students at a time, sometimes you have to kind of send, here, try this and try that, and you kind of want to reuse content. So there is a different way of drawing things. There's a second model for drawing things, right? You have paint programs, right, that are pixel-based, but you also have diagram editors, right? You have a diagram editor for drawing vector-based diagrams. So if this was a drawing, this example here, this was drawn using our new approach, which is we treat it like a diagram editor. So if you click on a symbol, what happens when you click on something in a diagram editor? You get your resize widgets where you can resize things, right? Or if you grab a symbol, you can just grab a symbol and just drag it anywhere you want. Or you can sort of group things together by just highlighting them and then moving them as a group, or applying an operator to that highlighted section. So so this was based on a diagram editor model, and users are free sort of to move and edit symbols without constraint. Now there is a trick here that we came up with, which was when you draw symbols, math symbols, and you put them down, it becomes they subtly snap to certain baselines, almost invisible to the user. And by snapping to a baseline, it actually makes the problem of recognition very easy. In other words, I can recognize what a student draws because with the pen recognition system, the failure was because I didn't know what you were drawing, because character recognition was high, failures were high. But I also didn't know exactly where you're putting the symbol, right? But if I snap to a baseline, here I know exactly what symbol the user typed, because there's no ambiguity, and I know exactly where they put it in which line, right? So actually recognizing this is actually very simple, and I'll show you a demo in a second. So here is also, with this diagram editor model, easy to copy, paste, and so on. And then you can also put figures in and manipulate them in a consistent fashion. So this model here is consistent with like GeoGebra, right? That you drag, your diagrams in here would be manipulatable in that same way. So this was here is not a chat. This first program we did was an equation editor, so that it was just a demo to see if it would work, and it wasn't as a chat program. And so what would happen is you'd have your palette of symbols, you can draw stuff, and this would be LaTeX code, so this would be recognized and converted into LaTeX, and this was a preview image of the LaTeX to show that it was exactly what you did. Now, I showed you how the mouse works in terms of resizing. The keyboard would work actually in the following way. So you could type on the keyboard, and when you're typing, alternate symbols would show up, right, in palettes, so that the shortcuts would be intuitive. So you could move the keyboard cursor anywhere on the screen you wanted to by in sort of half increment steps, so you can do exponents and other things. Just you can cursor around, and each time you type a character, an alternate symbol would appear, and you can select them by tab or pressing the key again multiple times. And the keyboard shortcuts would be done in an intuitive way, such that let's say if you wanted a less than or equal symbol, what would you type? Well, you don't have less than or equal on your keyboard. You type less than, and then one of the alternatives would be less than or equal to. Or you could put it as L for under, but actually both under less than, or under L for, in English, less than or equal to, right? And alpha, if you wanted an alpha, you would think of A, right? So if you didn't want to hunt in the menus, you could always find them there, or you could use the keyboard. So let me just give you a video here, if I can just escape out of this for a second, to show you the how this recognized expressions. Okay, I don't know if we. So here it's you're just drawing the symbol, and you can sort of just move things around. It's just purely a picture, and so you're free to sort of, and it recognizes here is latex and here's the output. So it recognizes, it's very easy to recognize this text even though it's just a drawing. So for example, if you see, as you can see as you're typing, alternate symbols sort of appear. And so let's say if you make sort of an expression like this and you decide, oh, I'm going to invert this fraction. Well, it's just, like I said, it's just a diagram, so you just basically, you just move things around, right? Grab things, move them around. And as you can see, every time the text gets sort of recognized, or if it's converted into text. So if, for example, you want to move this root here, you would just say, oh, okay, I'm going to move that. I don't know why you would do that. You can just easily it's just purely a diagram based on diagram editor principles. So this is not just for math chat. This was a formula entry, but that this sort of same model could be used for both formula entry and sort of for chatting. So let me get back to what's the full screen shortcut?
View. That's okay.
View.
View. Move down.
Yeah.
Control H. Control L.
Oh, L?
Two more tools. Go.
Yes. This one? Okay. All right. So we did a study on this where we observed novice users, right, entering expressions, right? So we only had 8 students enter 8 expressions, right, in the diagram editor. Versus we had them write them on a physical whiteboard, which simulated paper because we were videotaping, so we needed a bigger surface, right? We did that physical whiteboard. We did a structure-based editor, and we did this sort of entry system. And students quickly understood, like this entry model, they actually quickly understood the entry model right away, how to enter stuff. There was didn't really a learning curve. The structure-based editor, though, they had to learn how to change the writing style. So with a structure-based editor, they definitely wrote things in a different order, and they had to, and often they actually, got stuck in that they had to, restart their expression. The diagrammatic approach was actually faster for entry, and the important thing is they wrote things exactly in the same order, essentially, as they would on a piece of paper. Now, this study there may be differences in the sense that this study was for copying. I mean, we gave them a list of expressions, so they copied expressions. So I don't know, we didn't do the study on, and we will do some other studies, but, for example, when students are working out mathematics, what order do they do things? Is it the same as if when they're, copying an expression? I don't know. It's actually interesting because in mathematics, if I were to look at text, how do people read text, right? The co-author on this study, he's an expert on reading text. And there are thousands of papers on how people read. What do their eyes look at when you look at a line of text? Where are your eyes looking? How do you sort of parse words and so on? But I looked around, and nobody's really done anything on mathematics. So when you take a very complicated math expressions, nobody's done a study yet, and I plan to do that. Basically, to have eye tracking equipment, and so my plan is to study this. But I'd be interested to see how, because it would tell you a bit about the brain and what it's thinking about when what parts of the expression do you look at first, and how do you, in what order, and so on. That I think might be important to understanding how people understand mathematics, right? But like in text, there's thousands of papers in math, other than the very simple ones with like x plus y, like just inline text. Nobody's looked at big expressions and how people read them, which I find interesting. So that's a study that I'm interested in doing. So basically, the diagrammatic approach leads to less. I would say leads to less dual task interference because people are doing nothing different than they would have otherwise. And it's easier for students to modify expressions that are deeply nested. So this might be good for communication, where you want to sometimes say, okay, step through this problem, modify this, right? So we're working on a prototype interface, and I have one developed that is, we did basically a collaborative version of this now that's browser-based. It uses SVG diagrams. We don't have the I didn't put the recognizer in because I want to put everything. The recognizer was on a server side before. I want to put it on the client side, and there's a reason for that, because I think that you can make mathematics more interactive if it knows what you're writing. Like when you're putting symbols down, I'd like it to recognize it then. You could do pen input, so it's possible actually to so far we have structure-based, we have pen-based, we have tech input. And it's possible actually to get all, and also there's also touch interface there, the way people interact with that. But it's possible to get all of these working in a consistent fashion. That in terms of user interface, of course we have sort of additional drawing tools, and there's sort of a chat window as well. And it's all completely based on it's all browser based, no plugins or anything. Yeah.
One question.
Yeah.
I think you have spent pretty much of your energy to solve these problems on online courses.
Yeah.
So what is the particular math course that you wanted to use this? Which is math class? Which subject?
Particularly? I mean, mine, I would use this in, I've used, basically, in the old program, I used in, let's say, calculus or discrete mathematics, right? I think there's a big need in particular in statistics. Now, I don't do statistics, but in statistics there's a big need because the formulas are fairly complex and the student level is very low. Like in terms of their understanding, at our university we have non-calculus based statistics.
So, for example, if you do on calculus, then you have a standard the problems that the student deal with, particular examples. Why don't, if you have taught the course many years, then you must have basic materials which was typed in with these mathematical expressions. Like so why don't, I think you use MS Office, MS Word usually to write those documents for homeworks.
For homework, I use like LaTeX, but
LaTeX. But students are not familiar with that. LaTeX. But you can easily change the LaTeX to MS Office document, MS Word. Then why don't just give it to them so they can make changes on it? Then it's much easier to develop this math jacks and things. I have used it before. But in student side, the students are, if we like more, when we give some sample file, and then they just make changes. Then they don't have to learn anything. They don't. They can save a lot of time. So just give them and make a change and upload it and share it. Then you can solve all the problem without any difficulty. And
so in terms of communication or like...
they can upload the file. Student. Not only text. They can always attach it the file. So I solved that problem in that way. When I teach the linear algebra calculus, I give the sample file so they can start with it. Then if you make it very easy one, then they do it. They do those homeworks. They solve the problems in a very easy way. Don't spend the time. They don't have to learn anything. And just do it. Make some change. Make some mathematical symbols and functions, and just add things. So they can share it. Later, when you need it, you supply some basic materials. Then they go in. After a month, they are doing better than us. They can, because they know those mathematical symbols are here. Cut and paste, and they make changes. They just learn it in very quickly. And also some of students are doing very well already. But if you teach something new, then those students who knows it well, they don't say anything. Those students who never haven't done it, they speak loudly. So you hear.
But how would that work? Let's say if we were taking, for example, I mean, one of the things is, I think, on the general issue of formula input. So, for example, I had an online course, right? And all of it was, I don't like multiple choice, right? I can
show you.
Yeah. Okay.
I can show you.
So,
Here, let's just.
but let's say students are required, then you have an online quiz.
Okay.
Right? Your student is required to have.
Okay, I will show
Yeah.
my. Okay, I will show my experience.
Yeah, okay.
Here communications.
Yeah.
Here and Q&A here. So I made a lot of discussions
Yeah.
like this. Here, for example, if we solve some problems, and
Yeah.
problem 7 in chapter 10,
Yeah.
for example, and here students were able to. Everybody can do. Communicate with this. Here, I gave this, for example, I could give a sample files. Here, all the student can have to do is just I gave us 3 by 3 matrix here, and they make the sample file. They made 1, 2, 3, 4, 5 by 5 matrix. They can just add something here and there or something like that. So if I give sample file. Then the student can make a change without much things. And some of the students will do it, and then they can go through it. If a couple of students do it, and share those experience in the discussion, in the bulletin board, the BBS, then other students follow it without hesitation. If one student do it first, then the other student can do the 7 by 7 or whatever, more complicated and better. So those students who really were not prepared, they see others are doing well, and they felt they are behind. So they started to get work. But if you just teach the new things, then you lose maybe. So the way that I choose was this. If I go at the very end, very first, here, I gave some sample files here, lectures and solution exams here, something after here, for example, first class introduction sample. So I gave a sample file at the early stage. We need only 1 or 2 weeks of materials, which has a certain problems, and then from the early years, here's attached files here. And anyway, so that was the way that I tried to do. In the early case, it was easy and solve it and shares it. So mathematical symbol was not a big deal for our student. So I think you are using some file to communicate the digital. So you should have some files. So if you share those, so students do make minor changes on it, then students can easily catch up yours to go further. So that would be much better, much easier than developing all these. So this is very important.
But this is for real-time communication, right? Which is a little bit more difficult when you. So the way so let's say if I have an example of a conversation with a student, I don't say, okay, student doesn't say. See, with the old text-based system before, student would say, all they ask me is, can you solve question 3 on page 41? And I don't like that type of conversation because then I'm dictating. So what I want to do is I write an equation. Like they ask me, I have a problem. And I do a little bit of it, and I say, now you do the next step. Because I don't want to it's not about me showing them how to do work, they have to participate as well. It's about getting the student, doing half the work, right? So they have to be able to complete the expression, and online, in the expression maybe they haven't.
But also, so this is the way that I have done it. Here, for example, so in that case, I think you are asking too much at the early stage. Here, if I'm the case, then the way that I have done is this. Here, for example, if we have materials like this, for example, then the student don't have to type it.
Yeah.
But actually, there are many materials already.
Yeah.
For example, if we are thinking about the matrix algebra, then if we have a mathematical symbols like this, then we can easily copy this. And here we can, in here, for example, if we go to the list and make a new discussions, then here, then they don't have to type it.
Yeah.
So and also they can make questions here.
Yeah.
Real-time communication can be made
Yeah.
in a more proper way, more quickly, without difficulties.
Yeah.
So what I'm thinking is this is test and save. And so this what I'm thinking now is in the real-time discussion, if you expand your horizon too much, that we don't need it.
Yeah.
This discussion is should be related with the class, our lectures.
But
don't go too far.
Okay. But I'm
just
thinking,
one step further.
So let's think about let's say calculus. You have a chain rule question.
So my student, I used that method. I give a sample file, so student can find the new problems and new solutions and be shared and gathered to be prepared. So this solution page was made for whole course. So students started to study this before their exams. So their performance was much higher, and also their satisfaction was much higher. And also, those could be shared with other students, and those tools were also shared like this. So, if we approach it in a proper way, we could do much better. And so this was my approach, and this could be one way, but I was not very successful in this way. So we'll see. Yes, it is. Okay. Yeah. Why don't you go finish up?
Almost just one slide left. So, we already get at this. Do we have? Okay. I think that the problems. I think one of the things, of course, is the smartphone is a problem in the sense that you have this small screen, right? If you're doing mathematics on a smartphone, you have a small screen. And the problem is that the virtual keyboard on the when you type in any text box, how it takes up the whole screen, or 60%. If you have a browser bar in the top, it's like 60% of your screen is gone based on this keyboard. And if you look at sort of typing symbols, other than your first series of text, like just letters, a lot of stuff is not that accessible because. You start getting into, I find even writing even capital letters on a smartphone, like if I'm trying to write nice formatted text on like if I'm just writing just all small caps, that's easy, right? But when I want to write nice punctuation, finding them on the virtual keyboard sometimes is very difficult. Like, not difficult, but you're 2 or 3 clicks down, right? So I think the thing is for a smartphone, we have to to do mathematics, we have to have sort of the virtual custom keyboard, right? You can't rely on the current sort of keyboard. So I think that my point in this talk is I think there's a need, I think, for real-time communication technologies to increase student engagement, whether it's in the classroom, whether it's outside of the classroom, right, for office hours. I think I want to increase in student engagement so we have that same level of engagement we have in other classrooms that are not mathematics. And I think that there's a lot of challenges still, especially for novice users, because math students are often novices, especially in the service courses, or I'm thinking those psychology, statistics students who really, really hate math, right? Because they don't never even taken calculus or anything. And I think it is possible. I mean, I've designed some prototypes here where you could take all the methods of input. See, for the instructor, sometimes text might be the fastest way. Because and for the student on the other side, maybe some of them have a pen, maybe some of them they like the mouse, some of them like the keyboard. And it's actually possible to combine all of these into one interface. So right now we have all types of different mathematical technologies. And I think that they actually, when I worked out all the user interface things, they're all consistent with working under the same. You could have one interface that actually allows for all methods of input so that the user chooses the method that they're most comfortable with, right? So I think that you're far away from sort of getting that chalkboard, even replicating the chalkboard conversation. But getting back to the recognition, so I showed you how I could recognize these drawings that you have, that people drew. And I think that the potential, that was on the server side. And I'm going to move that code hopefully to, that code I didn't write. That I downloaded and modified, right, with some open source. So I need to get, and it was written in a language, tree transformation language. So, which is, so it's not like something like I know very well, right? So I want to convert that into JavaScript so that I can have the recognition on the client side. And one reason for that is that I see a way of, I think it's really important, if you think about calculus, right? You think of calculus notation, right? You think Newtonian notation versus Leibniz notation. What's the brilliance of Leibniz notation is that it suggests you can do things without you having to think about what you're doing, right? And so mathematical notation, a good notation, for example, frees the mind from some trivial details. I mean, they're important details, but they're also, it lets you do some bigger, more higher level stuff. Mm-hmm. And so the idea that I'm thinking of is that if we have the recognizer on the client side, mm-hmm. then I could do things like, let's say if you have an equation and you're moving things from one side to the other side, it could do the little things like change the sign for you or do some of the manipulation, so you have a computer algebra system it can interact with. So the student can then focus on the main points of the question, where you could get some cognitive assistance for the mundane things, so the conversation goes quicker and they can understand the big points, as opposed to, sometimes when you watch a student in your office and they're mm-hmm. getting confused about the little things mm-hmm. and they're not seeing the big picture. So mm-hmm. I think that first let's try to replicate mm-hmm. the chalkboard conversation, and then we can go beyond that, something that's actually better than a piece of paper because it has all the freedom, but it also has the ability to be interactive in its so that's kind of where I'm heading with once I move
Okay, for that, for one possible answer for your final conclusions, what if we use, I think it's the one that I have shown here, this is basically using the LaTeX here, the command which shows it. So I think we are working, we agree with the kind of approaches, but I think there are the easier way here too. For example, if we have a matrix algebra here, then actually we already have the most of the examples and things. We can find the many things on the web. And so if it's well arranged, then we can teach. When we teach it, we can copy all those things, so we don't have to worry. But also, when we type it and express something, then we can use the things like this. For example, here, what if this is a Python-based Sage Sage languages here. I think we did it. Okay, here. Okay, for example, if we this is a Python language basically. So if we use this command to express the functions and matrix and things, then we can find the answers here. Then we may file, and here we may use the code like this and the solutions like this, even with the questions or things like that. For example, then we may use something like this. With this, if we can change the function after the questions here and code and solution for something like this. So then the student can make easily
Yeah.
the documentation of their solutions and
Yeah.
problems and their approaches. So then it can be shared in the discussions of the class here, like this. Then in my case,
Yeah.
we didn't have any difficulty
Yeah.
to communicate
Yeah.
the mathematical concept
Yeah.
or solution of problems to help each other.
Yeah.
So I think I thought this could be an answer for your questions.
Have you tried this in a calculus class? Or
Sure. Calculus, yeah.
Like templates?
Oh, sure. The calculus, definitely. Definitely. Calculus. Here. Calculus. Here, linear algebra, calculus. Here. For example, multivariable calculus for the equation of line and planes. And the same thing. I have so I can copy these things. 그리고 이 박사, 이거 저 3D 되는 거 있죠, 자바. 이거 저 바꾸면 다 돼. 최고에서 다 돼. 지금 3D 그 이미지 다 나와요. 오케이, 그 이 주소만 바꿔주면 돼. So we could have. So like this, it's all in English. So at least if we have a proper textbook and things, then we can copy these things, and the student can save time to type those things, and for example here, copy it, then share it, and here. So and if you have little to them, then they can make their own and things like that. So nowadays we already have for service courses like calculus, linear algebra, or differential equation, or engineering mathematics. Now we have really some good stuffs here and computation tools like this, and all the code here and the equations here. In that case, mathematical communication through online is much easier. So when I teach my class with these materials, with the proper textbook and content, then actually there's no communication difficulties because they learn it, they go there, they don't have to retype it, they can share it, and also for those problems that they have to type when they need, since we have a textbook, so we can supply the file, so they can make changes on it. So in that case, the question that you had was already resolved. So there are ways. It has been discovered and recovered. So many professors who teach mathematics try to communicate online, try to find some ways, and this could be one way that answers your questions. Okay. And any questions? Any comment? The Carjanto? Yes, sir. Nathanael?
Well, Cariato is my name.
Nathanael, yes.
Do you have to install this program?
No, I could show you maybe.
Yes, you can show.
We'll see. It's
okay here. He will show.